This is my second video lesson for Unit 10. In this lesson, we'll be analyzing equations using Table I. Go to page 10 in the class packet. Motivation. Which of the following are physical or chemical changes? Ripping paper is a physical change. Boiling water is also a physical change. Burning wood is a chemical change. Dissolving salt in water is a physical change. Digesting food is a chemical change. And rusting is a chemical change. Learning target. At the end of the lesson, I will be able to write a thermochemical equations of chemical and physical changes using Table I. Homework number 2 will be a junopod based off this lesson. Just to review, a physical change is when a change happens and no new substances are formed, while in chemical change, you are forming new substances. Here we have delta H, which is the heat of reaction or enthalpy. If delta H is negative, that means it is exothermic. That means energy is being released when reactants become products. If delta H is positive, that means the reaction is endothermic and energy is being absorbed when reactants become products. In a chemical equation, where will you write the energy? On the reactant or product side? If it's an exothermic reaction, you will write the energy on the product side because energy is being released. If the reaction is endothermic, you're going to write the energy on the reactant side because energy is being absorbed. You're not subtracting energy anywhere in this equation, so you do not want to put a negative sign next to the energy. Here is Table I, which lists out various equations and the delta H. If delta H is negative, it means it's exothermic. If delta H is positive, it means it's endothermic. These equations are also known as thermochemical equation, which is an equation of a chemical reaction that includes a quantity of energy that is released or absorbed. These represent chemical changes. On the bottom, these equations represent physical changes. These are ionic dissociation equations. On the bottom of Table I, it tells you if delta H is negative, then the reaction is exothermic. On the Regents exam, whenever a question asks about energy of an equation, chemical or physical, you have to use Table I to look up that equation. Sometimes the question will not tell you to go to Table I. Ionic dissociation equations can be found on the bottom of Table I. It is an equation showing an ionic compound dissolving in water, which is a physical change. The products are aqueous ions. You can see in each equation, the salt, when it dissolves in water, breaks up into ions. One way you can identify an ionic dissociation equation is that it has water on top of an arrow. Thermochemical equations do not have this feature. Learning check number 1. According to reference Table I, which statement best describes the formation of HI? Pause the video and resume once completed. If you look on Table I, HI has a positive delta H, therefore it is endothermic and heat is absorbed. Choice 4. Learning check number 2. According to Table I, which salt releases energy as it dissolves? Pause the video and resume as completed. You're looking for an ionic dissociation equation that has a delta H that is negative. The only one that has that is choice 2, LIBR. This is review from Unit 5. Breaking absorb releases forms. Breaking a bond or attraction absorbs energy. Forming a bond or attraction releases energy. In a chemical reaction, there's a bond breaking and bond forming step. If the energy involved in bond breaking is greater than bond forming, it is endothermic process. If the energy involved in bond breaking is less than bond forming, then it is an exothermic process. Learning check number 3. According to reference Table I, when 1 mole of ethene C2H4 is formed from its elements, 52.4 kilojoules is what? Pause the video and resume once completed. The answer is choice 1, stored as potential energy. Learning check number 4. The diagram below represents the energy change that occurs during the formation of a certain compound under standard conditions. According to reference Table I, the compound could be what? Pause the video and resume as completed. If you look at the potential energy diagram, it is an endothermic reaction because delta H is positive. the potential energy of the products is greater than the potential energy of the reactants. If you look on table I, the reaction involving HI is endothermic. Therefore, the answer is choice 3. Learning check number 5. Given this reaction, an alternate way to write this equation is what? Pause the video and resume as completed. Since delta H is positive, you have to write the energy on the reactant side. So the answer is choice 1. For this practice, use table I to write the energy onto the equation. Pause the video and resume once completed. Here are the answers. Let's say you're conducting a reaction in a test tube. If the reaction is exothermic, how would the test tube feel? So in this scenario, we have a test tube. We are conducting a reaction inside the test tube. We have two reactants, a circle and a square, reacting. Once they react and form the product, it releases energy because the reaction is exothermic. So how would the test tube feel? The test tube would feel hot. If the reaction is endothermic, when the reactants react and form products, it will absorb energy from the surrounding area, so the test tube will feel cold. Learning check number 6. A student observed that the temperature of water increased when a salt was dissolved in it. The student should conclude that dissolving the salt was what? Pause the video and resume as completed. Since the temperature increased, the salt was releasing energy when it dissolved. Therefore, it was an exothermic reaction. Choice 3. Learning check number 7. Given the reaction, what is the approximate delta H of formation of 1 mole of H2O? Pause the video and resume as completed. In the equation, the formation of 2 moles of H2O releases 571.6 kilojoules. Therefore, this reaction is exothermic because the energy is written on the product side. So if you have 1 mole of water, it will be half of 571.6. And since it's exothermic, it will be negative, so the answer is choice 1. So if you have 2 moles of H2O, that will be negative 571.6 kilojoules. For this practice, use table I to identify if the equation is endothermic or exothermic, then write the energy onto the equation, and then identify if it's a chemical or physical change. I will do the first question as an example. Using table I, this is an exothermic reaction because delta H is negative. 44.51 will be written on the product side of the equation, and this is a physical change because water is on the arrow. Therefore, the sodium hydroxide is being dissolved, breaking up into ions. Now try to do the rest of the questions on your own. Pause the video and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Junapod homework.